Hi guys, good evening one and all. Meanwhile, do you have any doubts from the last session or previous session? What we have discussed about rigid frames design. We just completed till I think supports part. We have to apply loads and design. That is the pending now. We'll see in this session. Till now, do you guys have any doubts?
No, sir.
So is it clear to all of you, right?
Yes, sir.
If you have any problem in understanding or something, any problem technically or physically, please tell me whether you are understanding or not. Please let me know. Okay, so that I'll try my best to make you understand. Okay. Okay. I have. I'm seeing here only 5 members. Okay. Till now. So okay. Let me continue. So you guys have no doubts till the last session. So I'm continuing where I have left in the last session. So let me share my screen. Yeah. You guys are seeing my screen, right?
Yes, sir.
Yeah. Fine. Thank you. So in the last session, we have seen up to supports. Okay. We have seen up to supports. Now let's continue this one. So after giving supports, we need to give loads. Okay. So the next one is loads. So yesterday we have discussed what are the loads coming onto the structure. So if you see this, the load number one is seismic in positive direction. So before going to the seismic loads, you have to define a seismic definition. Okay. So how you will define a seismic definition? So in that, for that we have to, because we are doing it is AISA design, we are going to apply seismic by the reference of IBC, International Building Code. Okay. And that too, we are going to design the loads according to ASCE 710. Okay. Whatever the values we have done, seismic calculations, wind calculations, we have seen, right? What we have done, design wind pressure calculation as per ASC 710. Okay. So according to the 710, we have to apply loads. Okay. For this MBMA 2012, I am going to use to apply loads. And for seismic, I am going to use IBC, International Building Code. Okay. There is no direct provision for seismic. All the American codes will be acceptable with IBC, International Building Code. Okay. So that first I have to define IBC. So for that, I'm defining, sorry. So, okay. All this is syntax. I'll let you know how to do without syntax also. I'll let you know. Don't worry about all these things. Define IBC 2012. Since we are using here 2010 edition ASC 710, so the after that 2010 we have to use the IBC code. So I am taking IBC 2012 because it is coming after 2010 the edition. Okay. And the next thing for define, just someone is disturbing me. So after defining IBC, we have to give the seismic parameters. Seismic parameters means we have seen the last time, right? SS, S1 and R and something soil class and long time period. All of you guys have revised all these things. If you observe here, if you go to ASC seismic, we have seen R value, importance factor value, SS, where is that SS, SS, S1, all these things we have seen, right? So all these are called simply seismic parameters. So we have to give seismic parameters in this session. So first one, SS. So what is the SS value here? SS last time, for example, we have taken SS value. What is that? 0.057, right? 0.057. And the next S1. What is the S1 value in this example? Just I'm again requesting you all the people while coming to the session, please mute yourself so that other people will not disturb. Okay. Okay, guys. Thank you. SS is 0.057 in our example, and S1 is 0.032. All the guys, you remember all these things, right? We have seen in the seismic calculations. And SS, S1, and then RX. RX is nothing but what is meant by R? Response modification factor in X direction and in Z direction. Actually, Z direction no need, but as a formality, we need to give RZ. This is 3.5 RX and RZ. Both are 3.5. And then S class. S class means soil class. Okay. If there is no predefined soil class, actually there are certain classes A, B, C, D, E, and F, something like that. Okay, what is A indicates hard rock and B indicates normal rock, C indicates soft rock, D is medium stiff soil and E is loose soil. Like that, they have American code have defined the soil class. So if the soil class of the particular location is not known, we can take soil class 4, nothing but soil class D, that is medium stiff soil. That is not too loose soil, that is not too hard soil. So we have to take on an average soil class 4, soil class D, nothing but. Soil class 4 in the sense A, B, C, D. D indicates 4. Okay. Soil class 4 indicates soil class D. And then last one remain TL, long time period, 12 seconds. And in that, I have one more thing I missed. Importance factor. Yeah. SS, S1, I. What is the importance factor value? I 1.0. So all these things, don't confuse all these things. All these things we have seen in our example. In the seismic calculation session, we have seen all these things. I, R, and SS, S1, all these things we have seen, right? So those things only. If you see TL12, why I have given TL12 from the graph we have taken at the time, whether you guys remember or not, please go through the revisor sessions. So recorded sessions, so you can get them. So TL12 seconds we have seen in our example. That is the value TL12 I have given here. So here we have defined seismic code. Now seismic weight you have to give. Okay, seismic weight we have seen, right? Seismic weight. So there is that seismic weight. Yeah, effective seismic weight W, dead load plus some portion of live load into tributary area. Because there is no factor for or 25% or 50%, there is nothing like that for live load, roof live load. In the ASCE 7 code, we have taken 0, because if you go through seismic weight in the code class 12.7.2, In that you can observe dead load into tributary area directly they have given for the roof. Okay, because they did not take any value for live load, so that's why dead load plus 0 into tributary area we have taken. But practically most of the companies do 25% of live load. Dead load plus 25% of live load into tributary area. Tributary area we'll see what is tributary area, width into tributary length. So that is called tributary area. In this session, first of all, anything we are giving weights, you have to define self weight also, because self weight also impacts seismic. Okay, so self weight 1, and then how to calculate seismic weight. So okay, I'm mentioning all these things in the commented lines here. You can ask if you have any doubt. Roof seismic weight. So what is the formula actually? We have dead load plus 0 into live load into tributary, right? This is the actual formula we will do, but most of the companies for safety purpose they will allow 25% of the live load. 25% means 0.25, like that they will take. Okay, no need to give width here because we are doing 2D frame. In that width will be directly applied here, so we need to give tributary length only. Okay, all of you guys remember what is tributary, right? So in yesterday's example we have seen, so for that for the grid line 8, what is the tributary value? 7.5. Okay, width no need to give width, directly we have given geometry, right? Along with we have provided geometry. So we have along the width we have provided geometry, so no need to give this width now, because we have mentioned here tributary area. Tributary area means tributary length into width. Okay, so width already we have given in the geometry, so you need to give tributary length only. What is the tributary length? 7.5 plus 7.5 divided by 2, that is 7.5. Like that we will do. Okay, so I am applying this formula. What is the dead load in our example? Yeah, suppose length or widths we have changed, right? So don't bother about all these things. Dead load and live load, this is an example, sample example, that's why I'm taking rough values to explain you. So dead load is 0.3. Okay, so dead load is 0.3 plus 25%, nothing but 0.25 into live load 0.6. All these things, what values we have taken in example, that is the things I am taking here in the practical session. Except length and width and tributary, only geometry has been changed. The loads what we have taken in our example, those are the same loads I am taking here. Okay, so dead load plus 0.25 into live load into what is the tributary length here? We are doing tributary of 7.5, because the adjacent tributaries, if you see in the plan here, 7.5 plus 7.5 divided by 2, that is 7.5 average load width of the grid line 8. So that is the value I am taking here. So 7.5. I am not giving width here, don't confuse, because width along the geometry we have given width. This is 2D frame, we have given width in the geometry, so that is why I am not applying the width here. Okay, I'm not applying the width here because we have given width in this direction. We have provided in the geometry itself. It will calculate directly what is the width value. So that's why I'm not giving here. So now calculate this one. 0.3 plus 0.25 into, actually 0.25 is not there in our code, but companies will follow for some safety precautions only. Okay, nothing change will be there, nothing change will be there, just 25% of live load is just 0.6, but there will be nothing change if you give 25% extra. Okay, so dead load plus 0.25 into live load into 7.5. So you guys calculated anything? 3.375. I got it. Right? So the value I got here is 3.375. So if you observe, this will be in, sorry, kilonewton per meter. Kilonewton per meter. Okay, because we are not applying, actually what is the units for this? If you observe in our example, kilonewton per meter square, live load also kilonewton per meter square, these are aerial loads. Okay, so kilonewton per meter square into tributary length, kilonewton per meter square into meter. So what you got is UDL here. So okay, so you have to apply this UDL on the rafters, because seismic forces will apply at some particular level from the ground. So that's why we have to apply the seismic forces along these rafters only, because dead load and live load, if you see here, dead load and live load we have considered to calculate seismic weight. Those dead loads and live loads will be acting on the rafters only, not will be on column. They will distribute on the column, but they will not act directly on the column. That is why we have to apply seismic weight on the rafters only. So what is the numbers of rafters? 6 to 23. So for that we need one more command, member. So be careful that all the commands should be in capital letters only. Generally we will give, okay, member weight, members, all these can be taken as members. We are giving seismic weight here. So 6 to 23 UNI, uniform load, because it is UDL. Okay, UDL will be mentioned in the command like UNI, uniform force. We will not tell direction here itself, just will mention UNI space value. What is the value here? 3.375. We have calculated 3.375.
Sir, here one doubt, sir. It should
Yes.
not be, sir.
Sorry.
Hello.
Yes, tell me.
Sir, a sign should be it should be minus or be,
Just a minute. I will tell you. Okay. We will not mention any sign or any direction here in this command. Okay, because we have just defined one load here. How to apply this load on the structure, I will tell you. Okay, just now we have defined one load. Okay, we have defined load only here. How to apply, I will show you. So we have defined one load, right? So up to this, all of you clear?
yes, sir, yes, sir.
Okay, then we have to go for applying loads. So first, what is the load? First load, sorry. First load, seismic plus X in positive direction, nothing but seismic in positive direction, right? We have seen yesterday. What are the loads we have to apply? Seismic in positive direction. So first load 1 SE plus X. Okay, load is nothing but we are defining load here. That is first number, load case number 1. This is the name, whatever you can give, not only this one, SCISMIC. positive x or x1, x2, something, whatever you can give. This is your name. You are giving this name. Okay, this will not affect the syntax. Okay, but you have to give this one properly. Load 1 seismic positive x. Okay, I am giving like this. Now, what is the load I am applying? IBC load. Okay, so IBC load, here you have to indicate the direction, because there are two directions I am taking, positive x and negative x. So that's why IBC load x1. Why x1? Already you are defining direction here, x. What is the direction of seismic loads acting on the structure? Laterally, right? If the structure vibrates due to seismic, how it will vibrate? Like this, right? So there will be lateral force acting on the structure. So lateral force, here we are doing 2D frame, so there will be no concept of z, only x will be there. So one is positive x and then other one is negative x. Okay, in the first case we are applying positive x, direction 1. Okay, x direction positive, 1 indicates positive. Okay, after that, perform analysis. So after you are applying seismic load, you have to give two commands like perform analysis and change. Why you have to give? Sorry, there will not be full stop here. Okay, why you have to give perform analysis and change? Because if you observe, we are defining two loads here, seismic positive x, seismic negative x. These two loads are defined by this command. Okay, so nothing but this definition will be applicable for two cases. One is load case 1 and the second one upcoming load case 2. So this definition should be applicable to load case 2 also, so that you have to give. You should not apply 2 at a time, right? You should not apply load case 1, positive and x direction and negative x direction, both will not occur at a time. One by one it will occur, right? One by one. So first one, this has to be performed analysis, nothing but whatever the behavior of the structure due to this load, it has to perform analysis, and then it has to change for load case 2. Now we have to apply load 2, seismic negative x, same IBC load, IBC load x minus 1. Again, this has to be perform analysis change. Why? Oh, sorry. So guys, understand why I am giving perform analysis? Because for these two load cases, only one definition is there. Both loads will not occur at a time. They will be acting on the structure after one by one, right? So it has to take analysis for this portion, and it has to perform analysis, and it has to change, so that second load will apply here. That's why you have to give two extra commands for seismic only. Okay, these commands will be applicable for seismic only, perform analysis and change. Clear, all of you?
Sir, once repeat.
Okay, actually we are defining the direct UDL value here, right? Uniform value something. Okay, we are applying self weight. What I can say is seismic weight. We are applying seismic weight in terms of UDL. Okay, on the members, I can say rafters here. Okay, but IBC load, I am applying x in positive direction once, x in negative direction once. Clear? So positive and negative directions, both forces will not occur at a time, right? So one force act like this. Due to this, the structure will deform in this direction. After that, the second force will come into the account so that it will deform the structure in this direction. So first thing, the STAD has to perform analysis for first load case, and then it has to be changed to second load case, and this process will repeat until the maximum value. Okay, up to 12 seconds it will take, right? So TL, so it will till reaches the maximum value. These two cases will be repeated. So that's why you have to give command change. Okay, because these two are repeated cases. Okay, and will not occur at a time. It will they will occur one after another. So it has to perform analysis for one load, and it has to be changed so that this portion is complete. So it has to take second load. Okay, so that it has to perform analysis and it has to complete it here. That's why I'm giving the two commands here: clear, perform analysis, and change. So now it is clear.
Clear, sir.
Yeah.
Sir,
So
the change command only different. That's why.
no, change commands means if you observe here, these two will have same definition, right? We are applying same definition loading. So
Yes.
as I told you, these will not occur at a time, one after another, right?
Okay.
So it will perform analysis. So after completion, it should not take again this one into account. So it has to be changed. So that is why I have given change so that it will take load 2 into account. That's why I'm giving change.
Okay, sir. Okay.
Clear?
Okay.
So
Clear,
if you observe here, we have applied two seismic loads. So after that, what are the loads I have to give? Dead load, live load, or collateral load, and collateral load. So all these are gravity loads. Okay. So whatever I'm taking, I'm mentioning in the commented session, so that commenting lines, so that you will not confuse. So dead load. Yeah. Whatever the line you are mentioning with star, that line will not compile in the program, so that they will appear in the green color. Okay. So be mentioned that be make sure that whatever the line you are starting with star symbol, that will not compile in the program. Okay, so the next one I am applying dead loads. Load, so load 1 and 2 complete. Now I have to take load 3. Dead load, you can write like this: dead load, or simply you can write DL, anything, whatever you want. This is just a name. Okay, so what is the first dead load you have to consider here? What is the first dead load you have to consider in the gravity load?
Self weight.
Yes, exactly. Self weight. In which direction?
Minus.
Obviously, yeah, minus y. Y minus 1. Like this will give. This is the syntax for dead load. Self weight of the structure. Okay, why it is y? Since you are not mentioning anything, it is taking global. By default, it will take global. Y minus 1 means positive y towards upwards, right? Minus 1 indicates negative downwards, right? So that is why self weight 1 minus 1. And then you have to apply whatever the external loads. Nothing but there will be self weight due to sheeting. There will be self weight due to purlins, which are coming on these rafters, right? So you have to take that load. I have given dead load of 0.3 in this case, right? So that roof dead load is equals to 0.3. What is that 0.3 units? Kilonewton per meter square. I told you it is aerial load. Okay, it is coming all over the plan area, right? So 0.3 into, you have to convert them into UDL. How to convert this load into UDL? By multiplying with tributary. So as I told you, by taking example this one, grid line 8 will have tributary of mid of this one to mid of this one. So 7.5 by 2, 7.5 by 2. So that gives you 7.5. That is why I have mentioned also here. You can see the name 7.5 meter bay. Okay. So that is why 0.3 into 7.5. I am multiplying. What is the value? 0.2, 7.5. That is 2.25. Clear? So this 2.25, where dead load will apply? So on the rafters only, right? 6 to 23. So this is UDL. You are applying UDL on the members. So it will come under member load. Okay. There are different types of loads. Member load, nodal load, there are plate load, something. There are different types of loads available in the Stat Pro. We are applying this load on the beams only. So that's why I have taken command of member load. B, make sure that you are applying this load in kilonewtons and meter, because this is in kilonewton per meter, right? 2.25 is kilonewton per meter. B, make sure that units are in kilonewtons and meters. So where are the units? So meters and kilonewtons, right? B, make sure this while applying the loads. Okay. So member load, from which member to which member you have to apply? This portion to this portion, completely these rafters, right? So 6 to 23. What is the load here? Uniform load, UDL, right? Uni. In which direction it will act? Gravity Y or global Y. Okay, global Y. Negative symbol indicates downwards. Okay, positive symbol indicates upwards. Uniform load in global Y direction. Negative indicates downwards. What is the magnitude of the loading here? 2.25. 2.25. So is this clear? Right? This calculation and applying load methodology clear, right?
Yes, sir. Yes, sir. Yes, sir.
So the next thing I am going to apply the same way. Live load, load for live load. In this member load, member load, before going to the member load, you have to, I am mentioning here calculation part. Roof live load. Okay, what is the value of roof live load here? In our example, 0.6. So 0.6 into 7.5. So that is 4.5. So you have to apply 4.5 UDL downwards. On which members? 6 to 23 members. Because you are mentioning members here, you have to give member numbers here. Okay, 6 to 23. Uniform force, global Y direction minus 4.5 magnitude of the force. So in the similar way, load 5, collateral load, or you can say additional dead load. Anything, whatever you can take, that is no problem. Roof, collateral load. For example, any value I have given here. So nothing collateral load he has given. But if you, for example, for understanding purpose, I am taking 0.1. Okay. All this is example, right? All I am assuming, all the values I am assuming here. So 0.1 into 7.5, that gives you 0.75. So the same thing, member load 6 to 23 UNI GY minus 0.75. So you have completed gravity loads here. So what is the load remain? So wind loads, right? Wind loads, we have to apply wind loads now. So what is the wind pressure in our example? The same thing, the whatever the values I have taken here, I am taking that an example. So what is the QZ value I have got in our example? 1.14 for example. Okay, 1.14, the same value I am taking here. Wind pressure 1.14 kilonewton per meter square. So you have to apply this wind pressure by taking coefficients. So already we have seen how to calculate coefficients for an enclosed building, for something partially enclosed, we have seen, right? Wind coefficients here. So do you guys remember this thing? So right?
Yes, sir.
Yeah, the same coefficients I'm going to use in this case. Okay, for your understanding, I'm taking all these things. Just I'm pasting here, pasting as values only. Okay, if you observe here, the 0.22 will act towards the column, 0.87 and 0.55 will act away from the rafter, 0.447 again acting away from the rafter. That is why whatever the values away from the rafter or column, those are indicated with negative symbol. Whatever the value acting towards the member, it is indicated with positive value here. Okay, but while applying the stat, we have to consider global axis. Clear? Global axis. So global axis. Okay, so how to apply these things in our stat? So it is acting towards right, right? X direction, what is the what is the notation or symbol we have to use towards right? Only positive, right? X direction is towards positive in the stat, Y direction is towards positive in the stat here. Y direction is towards upwards, Y is positive. X is towards right, X is positive here. So like that you have to give. So if you take there is values. Okay, so this 0.22 acting towards the column, so it is in this direction. You have to apply stat in this direction only. So what is the symbol you have, what is the sign convention I have to use? Plus only, because X is towards right, it is positive in the stat, right? So 0.2 is positive. Okay, Y is towards up, Y is positive, right? So these two values also positive. Actually these two are negative because of the sign convention according to the actual provided by the code. But while applying in the stat, if you want to apply load in upward direction, so you have to apply positive, because Y is positive towards up only. Okay, that is why you have to change the sign convention to positive. This one also, it becomes positive, and this also, what is the value? It is acting towards right. Towards right, what is the X value towards right? Positive. So right, why I have taken all these values positive? Are it clear?
Yes, sir. Yes, sir. Clear.
Okay, don't confuse the sign convention between actual nothing but as per code and as per stat. Don't confuse the sign convention between these two cases. Those are different. These sign conventions are as per code only, but while applying these values in our stat, you have to take geometrical axis. Okay, towards X or towards right is positive in X, towards up is positive in Y. That is the sign convention you have to use in the stat. The same thing I'm taking here. Okay. The second case is reverse to the first case. Okay. If you see here, it is acting left. It is also acting left. So these two values becomes negative in our case, in the second case. Okay. So minus 0.47. Y value becomes positive only because they will be acting anyway upwards. 0.87 minus 0.22. So all of you agree with this?
Yes, sir.
Clear. So what about case 3? Case 3 is this one. I'm copying these values. Case values only. If you go to case 3 now, okay, again towards right, they both are acting towards right, and in y direction both are acting towards upwards. So all the values are positive again. So I'm changing the sign convention for stat. So it is clear. So case 4 again reverse of the case 3. So minus 0.11 because it will act negative xwards, negative x direction. Y anyway towards a positive 0.51 minus 0.58. Right. Clear. So if you take this case number 5. Case number 5. This is the case number 5, right? Okay. So if you observe case number 5, first value is acting left. So it will negative only. So it is correct. And if you observe the rafter values, those will act towards upwards. So they should be positive. So I am changing them to positive. And the last column value, it is acting towards right. So right is positive in x, right? It has not changed. Huh? So it is clear. And the last one, last case values, I'm copying. So again, if you see, this is negative and these three are positive, right? And the first one is negative and 2, 3 and 4, all these are positive. Okay, this is how we have to take sign conventions as per stat. Okay, now these are the coefficients you have got.
Sir, we can use up to 8 cases, right?
Yes, you can use up to 8 cases, but load number, nothing but what is the 7th case, 8th case you'll get. Already we have reversed these 2 cases, right? But we have not reversed these 2 cases.
Yes, right.
Okay, if you reverse this case and this case number 7 and case number 8 will come. Clear? Because maximum these cases will govern. Okay, maximum practically these cases will govern. You will after you practice, you get to know all these things. You can choose. You can see what is the case this is governing for a member. You can see how to see. I'll tell you all these things after the design. Okay, so you have got this thing. What is the wind pressure value we have got? 1.14. 1.14, right? Yeah, 1.14. Wind pressure is same for all cases, right? So tributary also, this is the same for all cases. What is the tributary value? 7.5. Why I'm taking like this, I'll tell you. So, okay. Just this is the wind pressure. What are the units of wind pressure? That is kilonewton per meter square. We have to apply the UDL on the column. So you have to multiply it with some length parameter, that is tributary length here. What is the tributary length here? We have got 7.5. So we should not apply full wind pressure for all the components in a particular frame. That is why these components comes into the action. So the final value what you have to apply, you will get by multiplying all these things. This thing into this thing into this thing. Right? So you can drag up to the bottom. Nothing problem. So all these, this one clear, right? Everything, do you have any doubt?
So I have doubt for the direction change.
Huh? Direction change. I told you. Just sorry.
The direction now, the previously coefficient value change plus and minus like this is.
I told you, no.
Because
This is the sign convention which is mentioned here as per the code provisions. If you see here, it positive symbol indicates towards the member, negative symbol indicates away from the member.
Okay.
But while applying these values in the stat, you have to change the convention into stat global axis convention. Global axis, if you see global axis here, x is positive towards right, y is positive towards upwards, right? So that is why these two axes, if you see here, these two are acting in positive x direction. That is why I have taken positive values. Okay. These two are also acting upwards. Y is positive upwards. That is why I have taken positive. But in this case, second case, if you see, these two are acting negative x direction. That is why first and last values becomes negative. Middle values becomes positive because those will be anyway acting towards upwards, right?
Okay.
Okay. That is how we have to change the directions as per the stat convention. Okay. Clear. So now the doubt comes. So here this value you have to apply. If you see case 2, this 0.22 value you have to apply for the column, left column, I can say. Okay. This 0.87 value you have to apply on the left rafter, right rafter, and the last value is right column. Like that you have to apply. That is why I am giving the numbers here. Just 1, 2 are the left columns here, 3, 4 are the right columns here. Clear? 1, 2, 3, 4, and left rafter is in between 6 to 14. Okay, 6 to 14, and here 15 to 23. Yeah, all these values are same, right? All these values, member values will not change, right? This Excel makes your works easier. Okay, that is why I'm taking Excel for all these things. Okay, so you are applying UDL right here. You are applying UDL. That is why I'm going to take uniform. This is towards, if you see, observe here, this is global x direction. uni gx. Direction no need to mention. Already sign conventions will come here. Okay, uni gx. And if you see, if you observe for rafter here, this direction, load direction is perpendicular to the rafter, not global y direction. Global y is towards straight upwards, right? But if you observe here, this value is perpendicular to the rafter. So that is why I am mentioning here, uni only y. So I'll show you how these loads will be applied. I'll show you. UNI GX. Uniform force, UNI means uniform force. You are applying in global X direction for 1 and 4 values, nothing but for columns you are applying global X direction. This will be acting straightly horizontal. But if you see this, they will not act straightly vertical. Okay, they will be normal to the rafter or they will be perpendicular to the rafter. That is why I'm not taking global into account. That is why uni only I have mentioned y. If you mention y, how these loads will act on the rafter, I will show you. Okay, let me copy all these things here. So hope all of you are clear with all these things, right?
Yes, sir.
So next I'm going to the STAD editor. So the next we have applied up to load case 5, right? Now I'm going to take load 6 and I'm mentioning it as wind load 1. Okay, all these are, we are applying all these in on members only. So that is why again I'm defining member load. Okay, member load. Just I'm copying all these values. So why all these things? Okay, fine. So like that I have taken just I am changing this font to this one. Just I'm applying a space button for all these things because you have to give one space over here. That is why I'm going to take space button. Okay. I'm not doing anything. I'm just, all these are simple Excel tricks. Okay. Okay, leave it like that. We'll see. So load case 1 is applied like this. Now load 7, wind load 2. So just I'm copying these things here. This is the load case 2. Okay. Actually there is one sheet with me, but if I show that sheet to you, you'll surely you'll get confused. That is why I'm taking this on Excel sheet. That is why it is showing some extra spaces, all these things. Okay. So load case 3, wind load 3.
8, sir. 8, sir. Load case 8, sir.
Load 8, sir.
8.
Okay, yeah, load case 8, exactly.
Member load is not required, sir.
Yes, I'll give. Anyway, we have to give member load for all these things. load 9 WL4 okay. We have seen this and I have to take this one. And load 10 member load 5. Okay, so we have completed wind loads and the last one last load case load number 12 and 3 temperature load 30. So temperature loads. Okay, there is syntax for temperature load. I'm applying plus. So this is the name, just this is the name, like wind load 6, wind load 5. This is the name I am giving. The syntax is that temperature load. Okay, there is one syntax for applying temperature load. So directly can apply temperature in degrees Celsius. Okay, so how many members are there in our structure? 1 to 23. 23 is the last number. So 1 to 23. Clear? So the same thing for freezing temperature also. So after applying the loads, so what is the
Minus will be 13, sir. Load 13.
sorry?
Load number 13.
Yeah, exactly. Load number 13. So okay. The other thing, one more load, there will be one more load number 14, mezzanine live load. We are not giving any mezzanine here. That is why I'm not giving any value. Just I'm putting heading. Just I'm putting heading only. I'm not giving any load because I have taken load combinations for all these things. That is why I have taken just dummy load case. This is mezzanine live load. If you remove this, you have to remove this in the combinations also, because I have prepared combinations including this thing. That is why I am giving dummy load case. Okay, so now let us see combinations. Okay, so